Good morning, everybody. Hopefully everyone had a good weekend. If you give me some green check marks in Blackboard, we'll get going. And thanks, guys. The final exam marks have been posted. I haven't come up with final grades yet. Some students had submitted some stuff last week, and I didn't get around to marking it. So if you go into your grades, it'll say final exam, and it'll tell you where you ended up. So I will have final grades posted shortly, probably today or tomorrow. And as well, we obviously have Unit 8 to go through here, which is just going to be a real short one. It's trig. Generally speaking, you guys have encountered this a bunch before, and should be nothing new or surprising, but we'll see. Maybe, well, I'll just ask before we get too far into this. Has anyone, okay, let's go with, has anyone done trig before? Sine, tangent, and cosine? You can like just type into chat, yeah, I've seen it before, done it before, never done it before. Sine, cosine, tangent. Never heard of it, Mr. B? Done it lots, Mr. B. That's all I need. Okay, no go from Connor. How about Eric, Jenna, Jesse, and Josh? A lot of J's in there. Jenna hasn't? Okay. Sometimes in Math 9, you will, I just thought you were really excited about that, Jenna. Sometimes in Math 9, your teacher will cover it. Sometimes they won't. Eric, Jesse, Josh, have you guys seen trigonometry before? If you don't know what I'm talking about, you can just say no. That's fine. There's nothing wrong with that. All right. It appears as if Jesse and Josh are MIA. Oh, Jesse's in. No. Josh, who knows? All right. So this is going to be new to everyone, which is good. It's only, you can see beside me here, that's basically 4 sections, but we'll finish it off this week. It's not long, it's not difficult, and it's basically just being able to use your calculator. So I'm going to give you guys a bit of a worksheet to do today. You guys can go through that and submit that probably on Wednesday. And then we'll do maybe a couple quizzes, and then we'll have a activity to finish things up. So that's kind of what this week has in store. I know that we start science on Thursday, but we have to get this out of the way first. So we kind of have 3 classes of this, and we might actually go a little bit into next week with this stuff. So it won't take long though. We'll be done in no time. In the course, at the very bottom, I have opened up Unit 8. And there's nothing really in there except for this one worksheet that we're going to do today. So if you go down to the bottom, Introduction to Trig, and it opens up a sheet that looks a little bit like this. We're going to go through this kind of together, and then there's only 5 of you, so we might just go through it all together. And it's basically just a bit of an introduction to trig. Before we get going too far on that, I wanted everyone to just kind of be on the same page with their calculator. So in your calculator, there are 3 different modes you can be in, and we need to be in degree mode. So if you have a calculator that looks kind of like this one, see if I can go in here and figure this out. This is all quite complex. Run math. Yeah. Let's go like this. Everyone in your calculator, if you have one near you, go tangent 45 or tan 45 and hit enter. And you should end up with 1. So clearly my calculator is in the wrong mode and I need to fix that. So if you don't end up with 1, you're like me, and we need to figure out how to get this puppy into degree mode. Some calculators at the top will have a little S, D, and R. Somebody in Zoom trying to talk to me. I don't have that up. Maybe Mr. Ross can check the message on Zoom and see what they're trying to get on about. Okay, I have a feeling somebody's probably just in the wrong place, because if they're signing into Zoom for the first time today, they're probably not. School. Who's school? Put in chat who you are, school. And we can figure out what to do with you. School isn't cooperating. All right, we'll just continue on. If you have this sheet open somewhere, awesome. If you don't, get it open. If you can print it, that's probably even better. If not, you might have to just jot some stuff down until you get an opportunity to print it. So basically what we're going to do is going to go through a little bit of an activity here that gets you guys familiar with the notation we're going to use to represent triangles, the notation we're going to use to represent line segments. It's really not terribly difficult. It's pretty straightforward, but we need to kind of go through it. So you can see we have this triangle, this big triangle. It actually has 3 different triangles in it. And at the top here it says observe triangle GBA. So when you see this notation, triangle GBA, what you want to do is, as soon as you see the triangle symbol, you know you're dealing with a triangle. You want to start at G. So here's G. You're going to go from G to the next letter, which is B, and then to A. So GBA is talking about this triangle down in the bottom here, just the little guy. So that is triangle GBA. Now, in every question we deal with in trig, Unit 8, we're going to have an angle, and that angle is going to be called the reference angle. Now, in this example, the reference angle is down here in the corner, and I might as well just label that. So this is the reference angle. And basically all the reference angle is just the angle that you're talking about in the question. So for this triangle GBA, the reference angle down here in the bottom is angle A. So if I said angle A, that means whatever angle is next to the letter A. So we're talking about this 21 degrees. If I said angle G, we'd be talking about the angle inside here. So this angle right here. If I'm talking about angle D, we're talking about this angle down here. So whatever letter we're using to represent an angle, angle E is up here, that's the one it's talking about. Hopefully you recall that if you see a little box in the corner, that means it's a 90-degree angle. So that lets us know that it's a right angle or 90-degree angle. And it's important to remember that our trig functions, sine, tangent, and cosine that we're going to deal with, they only work if you have a right angle. So if you don't have a right angle in your triangle, you can't use the trig functions. They're only for right angle triangles. Okay, I guess the tricky part is labeling the 3 sides. Once you're a master at labeling the 3 sides of a right angle triangle, you should be ready to rock. So you guys know if you have a right angle triangle, just draw one here, kind of a right angle triangle. Do you guys remember what the longest side in a right angle triangle is called? The one across from the 90-degree angle. Does anyone recall what that's called? C, yeah. And when we're using A, B, and C for the Pythagorean theorem, a squared plus b squared is c squared. For sure, that's C. It has a name. Does anyone remember what the name is? It always has to be C, the longest side in a right triangle. Starts with an H. It is called the hypotenuse. And I will abbreviate it forevermore as hype. Hypotenuse is the hype. All right, so that is the longest side in a right angle triangle. Okay, if our reference angle is down here in this bottom corner, we have two additional sides in our triangle. So there are three sides altogether. The longest side across from the 90-degree angle, generally referred to as C, is always the hypotenuse. It's always the longest side. That never is going to change. But the other two can change, and this is possibly where you're going to get confused. There are two additional sides, the opposite and the adjacent. And the opposite is kind of what it sounds like. If I have an angle down in this corner here, talking about this angle right here, which side is opposite that angle? Well, if I went all the way across the triangle over here, that would make this the opposite side. I should probably write opposite so we don't get confused. And I will abbreviate that one OP, O-P-P. So those are kind of the two that are kind of easy to recognize. The hypotenuse is the longest. The opposite side is whatever reference angle you're talking about. If you go all the way across, if you think about, I've seen, I'm not going to be able to draw this very well, but if you had like a can of spray paint and you press the button from this corner, like an aerosol can, which side would it paint? Well, it would paint the opposite all the way across the triangle. So that's a way to think about where the opposite is. And then that leaves the adjacent side. And that will be ADJ, adjacent. So those are the three sides in a triangle. You have the opposite, the hypotenuse, and the adjacent. I did mention that it can get kind of a little tricky from time to time, not all the time, but let's just maybe look at one quick little example here. If I draw the same triangle again, and I have my 90-degree angle down in this corner, let's say my reference angle isn't down in this bottom corner. Let's say my reference angle is now up here. So same triangle, but I've moved my reference angle up to the other side. This is still my hypotenuse because it's across from the 90-degree angle. It's the longest side of my triangle. But what's changing now? Well, if I had a can of spray paint up here and it's blasting out, it's going to hit the opposite side. So that makes this the opposite side. And then whatever side is left, the side that helps form the angle with the hypotenuse is the adjacent side. So two triangles, the same triangle, but now my sides have changed. So if I move my reference angle up into the top corner, my opposite side and my adjacent side have now switched. See how that works? Over here was my opposite because this was my reference angle down in the bottom corner. And then I had my adjacent over here. But now I've changed my reference angle same triangle, but my adjacent and opposite have kind of switched. So that's kind of where sometimes students will run into trouble. Once you establish which angle you're talking about, then your opposite and adjacent can be labeled from that angle. It's not as though you see a right angle triangle and then you can just automatically say, this is the opposite side, this is the adjacent side. That's not how this works. You have to have a reference angle before you can label your sides. But the important thing is that the hypotenuse never changes. That's always the same. All right, so there's a bit of an activity to go through here. We're going to try to find some angles. We're going to try to find some sides, lengths. I'll measure them for you so everyone kind of has the same numbers to deal with. But we're going to go through and just kind of fill out this, and then we're going to answer some questions about it. So here we go. Calculate, this is reading B here, calculate the missing angle measures of each triangle, complete the chart. Use a ruler to measure to the nearest tenth of a centimeter, all three sides of the right triangle. Use the chart below to record your data for each triangle. So we're going to kind of use the information given here to figure some stuff out. All right. We have in the chart, the first thing we have here, triangle EAD. Let's identify the triangle. So this whole column is referring to triangle EAD. So maybe I'll make triangle EAD my red triangle. So EAD. So I'm going to start at E. I'm going to go down to A. Going to go across to D. Back to E. So we're talking about the big triangle first. All right. Angle. This little symbol here that looks kind of like an angle means angle. So angle EAD. So what that means is just like when I write or identify my triangle, I'm going to start at E, I'm going to go down to A, and then I'm going to go over to D. All right, so EAD. See how those three letters form this angle down here at the bottom. So what is the measure of that angle? Angle EAD, get rid of this stuff, is 21 degrees. It's labeled already for me down here. So I'm going to put in 21 degrees. All right, the next thing down below is angle ADE. So this angle down in the bottom. I have the symbol here, which indicates to me that that is a 90-degree angle. So angle ADE is going to be 90 degrees. The last one is DEA. So it's talking about the angle here up at the top, DEA. Now, it's not labeled. I don't have a protractor. Is there another way I can calculate angle DEA? Anyone think of another way to find the angle? Surely somebody can remember how to calculate angle DEA up at the top. If I'm talking about this big triangle here, how could I find the angle on the top? All right. 3 angles in a triangle add to 180 degrees. So if I have a full 180 in one triangle, if I subtract 21 and I subtract 90, what am I left with? I'm going to be left with 69 degrees. So DEA is going to be 69 degrees. Forgive me while I throw this computer at the wall. All right. The next thing is the three measures of the sides. So obviously, it's going to be difficult to measure these, and everyone's going to be a bit different depending on how your printer prints it out. But if I have line segment EA, from E to A, and I measure it, I'm just going to give you the measures of these things, and you can just copy them down just so everyone has the same numbers to deal with, make life a little bit easier. So segment EA, I measure on my sheet to be 19.5 centimeters. Segment AD is going to be from A here on the bottom all the way over to D on the other side. So the length of this whole segment here is going to be 18.3. And segment DE, so that's this left side over here, DE is going to be 7.2. All right, so that'll be enough to get us going for the rest of the sheet. The next thing we're going to do is going to do the same process for triangle FAC. So triangle FAC is going to be the second triangle down here, and notice they share this angle on the bottom. So FAC, angle FAC is this angle on the bottom. Start at F, go to A, then end at C. It's going to be 21 degrees. The next thing I need to do is ACF. Here's A, go across to C, up to F. 90 degrees. And then I'm left with CFA, which is CFA. This angle up here is going to be 69 again, because they all have to add up to 180. Again, I'm going to measure the lengths. The first length or line segment I have is from F to A. So I'm doing this across the top. From F to A, this segment here, if I measured it with a ruler, that is going to be 16.2 centimeters. The next segment is AC, from A to C, so this bottom piece is 15 centimeters. And the last is CF, so this left side of the triangle here. It's going to be about 6 centimeters. All right, last triangle is going to be triangle GAB. So GAB. Angle GAB is labeled GAB. That's this guy here, 21 degrees. ABG. ABG is going to be 90 degrees. And that leaves us with 69 degrees for the last angle. They all have to add to 180. Segment GA, from here down to A. How long is that? It's about 9.5 centimeters. From A to B, so along the bottom of this small triangle, A to B, this length down here is about 8.9 centimeters. And BG, this length on the left side, is 3.5 centimeters. All right, so we need to know all of those lengths to continue on the sheet. Where do you get those past numbers? What are you referring to there, Jesse? What do you mean by past numbers? Like the segments? I used a ruler to measure them. So I printed off my sheet, and then I broke out my ruler, and I measured the length from A to B. And then, okay, sorry, I didn't make that very clear. So I measured them. The angles were given as 21. I know a triangle has to have 3 angles that add to 180, so I can figure out the top angle is going to be 69. And then I measured the side lengths for the rest of them. I would have let everyone measure their own lengths, but then the numbers would have been different and it would have worked out a little bit funny. Everyone would have been off by a little bit, which is okay, but I just wanted to make sure everyone had the same numbers so we could proceed as a group, all 6 of us. All right, the next part of the sheet asks us to generate some ratios. And ratio, you learned in grade 8 because I'm doing that with my 8s right now. Ratios are just another way of saying fractions. So we're just going to divide the length of 2 sides. So what we're going to do is we're going to take EA and divide it by AD. So we've already got the lengths up above here. So I'm going to go find length EA. We said EA was 19.5. I'll just write it over here. There's a little bit more room. 19.5. And then length AD from up above was 18.3. So I'm going to go in my calculator 19.5 divided by 18.3. 19.5 divided by 18.3. And I get 1.065. Let's go with 3 decimal places, I believe. Oh, it asked for 4. Write the decimal form round to the 4 decimal places. It says 4. So 1.0656. All right, so that is that first ratio. The next one takes AD and divides it by EA. Somebody want to do that one for me? Surely we can figure these out. Okay. AD, EA, divide them together, what do we end up with? Surely somebody can divide 2 numbers together. I'm pretty good at it. Josh, did you do it? 9384, I like it. 9384. All right, that looks good. EA divided by DE. Okay. What I'm going to do is, I don't want to divide these numbers, and you guys are fully capable. So I'm going to get you guys in 2 different groups of 3. There's 1, 2, 3, 4, 5, 6. And then you guys can work through it on your own and together, and you can just put the answers into chat, and you can go through it with the other people in your Blackboard group and see what you come up with. While you guys are going through that, I will start filling out the sheet. So we probably, to get through the 3 triangles here, I don't know, maybe take you 5 minutes. Let's go with 10. Let's go with 10 minutes. You can continue Going on into the sheet. So I'm going to give you guys 10 minutes to go through this with a group, and you guys can check your answers with one another. And then in 10 minutes, we'll come back and we'll start going through the questions together. So, see if I can manage this. I will pop into your groups periodically. If you have any questions, you can ask. But I'm going to put you all into 2 rooms. There you go. And just type into your rooms, go through it, and figure out what all these are. So we'll put up a timer for 10 minutes. I'll meet you guys back in 10, and hopefully you have this little table filled out. Thank you. All right, guys, welcome back. How did we do? Did we manage to fill out those tables? I'll bring everyone back to the main room here. There we are. Perfect. Did we get that table filled out? Yes or no? My microphone on here. Give me a green check mark if you can hear what I'm saying and you can see me. Yeah, all right. Okay, so Eric got it. Jesse, the math is easy, but I didn't have the numbers to do it. What numbers were you missing, Jesse? All of the side lengths are referring to something off the table on the first page. So what side lengths did you not have? Oh, should I have left it scrolled up, I suppose? Jenna didn't get anything. All right. Okay. Not really sure what to do with that.
Just go back to the first page, and I'll grab something like that.
Okay, Mr. Ross is going to grab a screen grab of the chart here on page uno. If you don't have it written down, I suggest you write it down, make your life easier, or you can measure the lengths of the sides yourself, but at least if everyone has the same numbers, we should be a little bit easier to go through the remainder of the sheet. All right, hopefully you had an opportunity to write down those sides. Now, as you kind of progress through the sheet, or not, you'll notice that there's some questions now. So write a sentence describing what you notice about the angles and lengths and ratios in your data. So just what do you notice? Maybe referring to this chart. Once you get this all filled out, you'll see that these side lengths have something in common. Just write it down below. After comparing your data with the group, well, we didn't get a chance to do that because we didn't get through part A, so we don't have to do that. On a half sheet of paper, you can just do it right here in this empty space for E. You don't have to do it on a half sheet of paper. Write a hypothesis about the relationship among the length of sides of the right triangles based on the information that your group gathered and discussed. So essentially what you're going to do is compare the length of each of the sides for all of the three triangles. Now if we go back right up to the top, when it says the three triangles, we have EAD, which is the big triangle, then we have FCA, and then GB. So these are the three triangles we're talking about. The second one is kind of like a hybrid of the first two, and the third one is a hybrid of all of them. So those are the three triangles. So that's what that's talking about. Letter F starts using some buttons on your calculator. So using your scientific calculator, find the 3 trig ratios for each triangle's 3 angles. Write your answers in the appropriate box. Different calculators work differently. We've talked about this a few times throughout the course. Some calculators, you have to write the number and then hit the tangent, cosine, sine button. In other calculators, you hit the tangent and then you hit the numbers and then you hit enter. So you'll have to figure out how your calculator works. Let's take it up from here next day. All right, so tomorrow we're going to start at letter F. So don't worry about F for now. We'll do the last little bit of this document tomorrow in class. So what we are going to do is you guys are going to go through this, fill out this chart, answer the 2 questions, and then we'll figure out what F looks like next day. As well for next day in the course, I'm going to upload all of the Unit 8 learning guide and the Unit 8 lessons. So we're going to go through the Unit 8 lessons for sure. The learning guide, I'll pick and choose a few questions so we don't have to do all of it, just because we're going to try to finish it off fairly quickly. And that's kind of where we're going to be next day. Does anybody have any questions about where we are, where we're going? I think we have class again tomorrow and then nothing on Wednesday, and then we have another hour on Thursday, if I'm not mistaken. And then Friday's badminton at the badminton club. I love badminton, so I'm pretty excited about that. All right, nobody has any questions. You guys should finish up to letter F on the worksheet for next day. We'll finish off section F and G and H and the rest, the second page, next day in class, and then I'll get you guys to submit this on Wednesday to go through that. So there you go. I'm going to sign off for now, and we will pick up from here next day. Thanks, guys.